So you, our listener, sent us down quite the rabbit hole this time. A really fascinating stack of excerpts from David Deutsch's The Beginning of Infinity.
Oh, yeah. And honestly, just wrestling with these ideas has been pretty exhilarating.
It really has. This is the kind of stuff that, properly stretches your thinking.
Yeah.
Makes you look at the world, differently.
Fundamentally differently, yeah.
We're tackling some seriously massive questions today. Like, are we just insignificant specks? Cosmic dust?
Uh-huh.
Is our planet just this fragile little spaceship, doomed maybe?
And what does it even mean for something to really exist, to actually matter?
Yeah. These are not light topics, are they? But the way this book tackles them is just, well, it's kind of mind-blowing.
It really offers a big perspective shift.
Yeah.
Challenges some, very deeply ingrained assumptions we have about our place in the universe, our relationship to it.
Exactly. So think of this as like your shortcut to grasping some really profound ideas without having to wade through all the dense philosophy yourself.
We've done the waiting for you.
We have. We've sifted through it, pulled out the most surprising bits, and we'll try to connect the dots in a way that hopefully sparks a few aha moments.
Yeah, hopefully it clicks.
So get ready, buckle up maybe, because this deep dive, it's going to make you rethink, well, maybe everything. Okay, let's dive in.
Let's do it.
The first concept that really grabbed me was this whole idea of challenging anthropocentrism.
Ah, yes. And what's so interesting here is the history, right?
Mm.
For most of human history, we actually believed we were at the literal center of everything.
The actual physical center. And the center of importance, too.
Right. Like everything revolved around us. Even natural events were often seen as having some direct link to human stuff, a god being happy or angry, that kind of thing.
It seems almost charmingly naive now, looking back. But it was the dominant view for so long.
And it's remarkable, isn't it, that even early sort of impersonal science, like Euclid's geometry, could exist alongside this. People using sophisticated math, but still thinking the stars dictated their personal lives.
Okay, here's where it gets really interesting for me, though. The book talks about the move away from those human-like explanations. Like the example of a missing jewel. Our first thought is a thief, right? A person with motives. We don't immediately assume the laws of physics changed in that room.
No, of course not. That's how we operate daily.
But for centuries, we didn't really apply that same impersonal logic to the universe as a whole.
Exactly. And then the scientific revolutions, starting with physics, they brought in these ideas of impersonal things, mathematical laws running the show. That was a huge blow to the old anthropocentric view.
Yeah, for the physical world.
And then biology followed, showing life itself wasn't some supernatural design project, but came from impersonal stuff like chemical reactions, genes, evolution.
And it just keeps going. Even our own thoughts, our feelings, our sense of self, the things that feel most uniquely human, now we understand them as physical processes in our brains.
It's a real humbling, isn't it, of our sort of cosmic ego.
Totally, which leads right into this principle of mediocrity.
Right. The idea basically that there's nothing particularly special or unique about humanity or Earth or our sun in the grand cosmic scheme.
Stephen Hawking's famous line about us being just a chemical scum on the surface of a typical planet, wow, that really hammers it home.
It's stark, yeah. A real jolt.
But the author makes a really crucial clarification here, doesn't he? Insignificance is specifically in the cosmic scheme of things.
Yes, that's key. By our own values, our human values, we obviously matter. To ourselves, to each other.
Okay, that's vital. So the principle of mediocrity is about correcting a bias, our tendency to think our viewpoint is the viewpoint, the universally important one.
Exactly. It's challenging that specific kind of human-centric arrogance, not saying we have no value as, thinking beings.
Okay, so maybe we're not the center of everything, maybe we're not cosmically unique. This brings us neatly to another really powerful metaphor, spaceship Earth. We've all heard that one.
Oh, definitely. The image of Earth is this, self-contained, finite system, recycling its resources, powered by the sun. It's a compelling visual.
Yeah, it emphasizes dependence, stewardship.
Right. The limits, the fragility, the idea that we could overload this system, like passengers on a spaceship running low on air or food if they're not careful.
There's a real sense of precariousness there.
And you can see the link to the principle of mediocrity, can't you? Both ideas, in their own way, kind of push back against human arrogance. They highlight Earth's tininess, its ephemerality, and the vastness of space.
Absolutely. It fosters humility, understanding our place. But then the book takes this really unexpected turn. It suggests the reality might actually be the opposite of what these metaphors imply.
Yeah, this is where it gets really provocative. The author makes these two bold claims. People are significant in the cosmic scheme of things, and the Earth's biosphere is incapable of supporting human life.
Whoa, okay. Those are fighting words, almost. They completely flip the script on what we were just saying.
They really do. Deliberately challenging.
So let's unpack that. The argument starts with, okay, Earth might be typical, but we, humans, we're far from typical matter.
Right. Think about it. What's the most common form of matter out there? Plasma. Super hot, light-emitting stuff. Stars.
Okay.
We, on the other hand, are infrared emitters. We exist at relatively low temperatures, made of complex liquids, chemicals, stuff that can only form at a very, very narrow temperature range compared to, say, a star.
So compared to the vast bulk of the universe, which is mostly this incredibly cold, dark, empty space,
Just above absolute zero, mostly hydrogen and helium.
we are incredibly unusual. The book even jokes that refrigerators might be some of the coldest, darkest places we can make.
It's a striking contrast, isn't it?
Yeah.
He paints this picture of typical intergalactic space, these huge solar system-sized volumes,
Right.
almost totally empty, so cold, only helium as liquid, no chemistry, no life, nothing really happening.
And then he brings it right back home to a place like Oxfordshire, even a seemingly mild environment like that, in its natural primeval state, lethal to an unprotected human.
Absolutely lethal. It's only our creations, our clothes, houses, farms, technology that make it livable.
So the Earth's biosphere, as it was originally, the author calls it more of a death trap for humans than some kind of ready-made life support system.
Even the Great Rift Valley, the cradle of humanity, barely survivable without the things we learned to make and do.
Which leads to this really fundamental insight. Humans aren't just adapted to some nice, welcoming environment. We actively created our own environment through knowledge.
Yes, and compare that to other species. Evolution equips them to survive in that harsh, resource-limited biosphere where, survival is a constant battle. Birth rates just barely edge out death rates.
The biosphere isn't designed for comfort or long life, is it? It's designed for, well, continuation of genes, maybe.
Exactly. Stability in the biosphere comes through constant individual hardship and death. So that spaceship Earth idea, implying this supportive system, it's actually pretty misleading when you look at the raw biosphere itself.
Right. It wasn't set up for us.
And the key difference for humans, the author argues again and again, is knowledge. Those early humans, maybe Neanderthals, living in Ice Age Oxfordshire, they survived because of tools, fire, clothing. Not because their genes were somehow suited to the cold.
Exactly. That knowledge wasn't biological inheritance. It was generated by human minds, passed through culture.
And today, someone living in the Great Rift Valley has a vastly better life than early humans there, thanks to better tools, farming, hygiene, all knowledge products.
So the biosphere gives us raw materials, the sun gives energy, but it's knowledge that turns those into a life support system for humans.
Other species get their survival knowledge encoded genetically, provided by evolution, by the biosphere itself. But ours is different.
It's like saying the biosphere provides, I don't know, sand and metal ores, but it doesn't provide the knowledge to build a computer chip from them.
Or a radio telescope, yeah. That requires human thinking explanation.
Which really throws cold water on that nostalgic idea of some perfect, unproblematic past, doesn't it?
Oh, definitely. The spaceship Earth metaphor can sometimes feed into that idea, a time when nature just provided.
Effortlessly.
Like the Golden Age myths, Garden of Eden, this idea of an existence without struggle.
But the reality, the book argues, and the evidence supports it, is that our ancestors faced constant, desperate survival problems.
The fact that we find so few fossils of very old people, that's pretty sobering evidence of how tough it was.
These concepts like grace or providence, this idea of unearned benefits, you can see them as ways people tried to reconcile that imagined easy past with the difficult present.
Okay, so humans are unusual matter. Our environment wasn't inherently supportive. The past wasn't easy. Now, the book shifts gears a bit into this concept of parochialism, our limitations.
Yeah, the limits of our senses, our brains, based on our evolutionary history.
It starts with the senses.
Yeah.
They evolved for immediate survival needs, right? Seeing right fruit colors, hearing predator. Richard Dawkins makes this point well. Evolution wouldn't waste energy developing senses for stuff irrelevant to survival back then, like seeing the precise colors of distant stars if you live on the ground, or having amazing night vision if you sleep through the night.
Makes sense. Waste of resources.
And the author extends this argument to our brains, bringing back the principle of mediocrity again. Our brains also evolved to deal with the specific scale of things in the biosphere. Human-sized objects, human timescales, the energies relevant to us here.
So most stuff in the cosmos, like tiny neutrinos zipping through us or massive quasars blasting energy across billions of light years, they happen way outside those scales.
Our senses can't detect them directly, and there's no built-in reason why our brains, shaped by this very narrow slice of reality, should easily grasp them.
That famous JBS Haldane quote comes in here. The universe is not only queerer than we suppose, but queerer than we can suppose.
Exactly. It captures that potential limitation, that maybe there are things fundamentally beyond our evolved capacity to understand.
Which leads to this slightly unsettling possibility that all our abilities, even reason, explanation, science itself, might be fundamentally parochial, limited by our origins.
That science might eventually hit a wall, a point beyond which the universe just becomes incomprehensible to human minds.
So, interestingly, the principle of mediocrity and the spaceship Earth idea kind of converge again here on this idea of a small, limited, human-friendly bubble.
A physical bubble for spaceship Earth, and maybe a conceptual inexplicability bubble for our minds.
But, and this is crucial, the author argues there's a massive flaw in that bubble concept.
Right. If the universe outside this supposed bubble of explicability is just unknowable magic, then what do they actually say about the explanations inside the bubble?
Doesn't it undermine them too? If there's this fundamental realm of stuff we just can't know, it casts doubt on the reliability of our knowledge, even about familiar things.
It starts to sound a bit like the old pre-Enlightenment split between Earth and the heavens, where different rules applied. It's a step backwards, almost.
Exactly. It ironically pushes us back towards a kind of limited parochial view, the very thing mediocrity was meant to fight.
So the author champions the idea that human problem solving, our knowledge creation, actually has a reach that extends far beyond our biological origins or the confines of the biosphere.
The analogy used is like birds flying to a new island. Their wings, their eyes, adaptations evolved in one place still work on the new island because they rely on universal laws of physics.
And our ability to generate knowledge is like that, but much more powerful. It lets us transcend our initial biological limits.
And while biological evolution is slow, human cultural knowledge evolves incredibly fast.
And especially since the Enlightenment, technological progress has been directly tied to explanatory knowledge. Newton's laws weren't just descriptions, they were explanations that eventually enabled things like, well, landing on the moon.
That leads to a really fundamental point about the connection between knowledge and what's achievable.
Yes, this powerful dichotomy. Any physical transformation you can imagine is either forbidden by the basic laws of nature.
Like building a perpetual motion machine.
Right, impossible. Or, crucially, it's achievable if you have the right knowledge.
Wow, that's a huge statement. It implies our ultimate limits aren't necessarily physical, but limits of understanding. If it's not against the laws of physics, we just need to figure it out.
Exactly. And this directly challenges that queerer than we can suppose idea. It suggests that, in principle, anything not forbidden is potentially understandable and achievable.
Because our ability to create explanatory knowledge is different. It's not just a fixed adaptation like a bird's wing.
Right. Those biological adaptations, like our DNA, are essentially, as Dawkins puts it, coded descriptions of the past environments where our ancestors survived.
Our genes specify the conditions we can survive in. Like the primate need for vitamin C is a perfect example.
Their genes lack the knowledge of how to make it, so they're stuck in environments where they can eat it.
But humans, because we understand the biochemistry, we figured out how to synthesize it. We can make it anywhere. We overcame that biological limit with knowledge.
And that same principle applies to living off Earth. A moon colony works not because our biology suits the moon,
Obviously not.
but because our knowledge lets us build the systems, create the air, the water, the environment we need, using lunar resources.
The example of Oxfordshire, with farms and factories making tons of vitamin C, it shows how knowledge transforms the environment.
And the author suggests a self-sustaining moon colony, using sunlight and moon rocks, is totally feasible with current understanding. It just requires applying the knowledge.
And the more knowledge we get, the more we can automate things. That old 99% perspiration, it becomes less true.
Automation closes the gap between the idea, the inspiration, and actually making it happen.
Future moon colonists might just take breathable air for granted, like people in Oxfordshire take clean water for granted now.
Because the knowledge required to provide it becomes embodied in the technology, the infrastructure. It transforms a hostile place into home.
So while just using knowledge for physical transformations isn't unique to us, our cells are chemical factories doing that constantly.
Right.
It's the creation of explanatory knowledge that's the real human difference maker.
Other animals might have some cultural knowledge, but it's limited,
Yeah.
like their genetic knowledge. The Haldane-Dawkins argument about limits might hold for them because they can't generate open-ended explanations.
So the author concludes, human reach is the reach of explanatory knowledge.
An environment is within our reach if we can create open-ended explanatory knowledge there,
And what do you need for that? Basically just matter, energy, and evidence.
which Earth and the Moon have in abundance.
And yes, we'll always have problems to solve. That's permanent. No utopian future without challenges.
But, and this is key, no particular problem is inevitable. Problems are solvable with the right knowledge.
This brings us to this amazing idea, the knowledge friendliness of the universe.
Yeah. Even seemingly empty intergalactic space.
Yeah.
It's not actually empty. It has vast amounts of hydrogen, potentially a huge energy source through fusion, if we figure it out.
And evidence about the fundamental laws is everywhere. We can build labs, study light from distant galaxies. The clues are ubiquitous.
The underlying laws are the same everywhere. The evidence is everywhere. Understanding and control are linked. This means even typical, seemingly barren places in the universe are potentially amenable to open-ended knowledge creation.
The universe is person-friendly if you have the relevant knowledge. Just like the Great Rift Valley is survivable today with modern knowledge, but was deadly without it. Same rules apply, just different scales.
The thought experiment of a generation ship, but in reverse, a small outpost, deep in space, just generating knowledge that illustrates this potential.
Even if, worst case, Earth's biosphere was ruined, our knowledge could, in principle, allow us to survive and thrive elsewhere.
Which leads to a radical rethinking of significance. The common view is, space, time, atoms, electrons, those are the big fundamental things. Humans are just tiny side effects.
Chemical stum.
Right. But the author argues that's a parochial view, stuck in our early Enlightenment perspective.
If you look at the long-term potential, colonizing star systems, maybe even controlling huge cosmic events, like preventing a nearby star from going supernova,
then the class of transformations achievable with knowledge absolutely dwarfs the spontaneous transformations that just happen naturally in the universe.
even explaining extreme temperatures, very hot or very cold, often requires you to talk about human actions, our technology.
And think about an astrophysicist's brain. It contains an accurate working model of something incredibly distant and alien, like a quasar jet. That act of understanding, spanning vast distances. Only knowledge creation does that. It shows an underlying unity.
Which brings us finally to the brilliant, slightly absurd example of the champagne cork in the Arecibo radio telescope's refrigerator.
Yeah, yes. Proxy for detecting extraterrestrial intelligence.
And what's so clever about it is thinking about what you'd need to know to predict that cork popping.
You'd need to know about humans, societies, technology, radio astronomy, the SETI project. It implies a vast web of knowledge about people and their creations, potentially far away.
The SETI instruments themselves, tuned so precisely to look for signals that could only be produced by technology, that highlights how certain types of knowledge-making radio transmitters or lasers might be detectable across stellar distances.
Biological evolution could never produce a SETI project. Only scientific explanatory knowledge can do that.
It's about making these explanatory leaps, right? Engaging with evidence you haven't directly experienced, like engineers predicting how a bridge might fail even if it's never built.
So the author argues these champagne corks, these little indicators, are proxies for all significant discoveries, all stemming from knowledge.
And the conclusion is pretty stunning. Humans, people, and the knowledge they create. These are actually the most significant phenomena, because understanding them, their potential, requires understanding everything else that's fundamental.
The difference knowledge makes is just immense. Think about an environment without it versus one with just a tiny sliver, as the book says.
Like the moon colony again. The matter comes from the moon, the energy from the sun, but the crucial knowledge initially comes from Earth.
And then the moon's substance itself starts getting reorganized, shaped by that knowledge, creating the potential for an open-ended stream of new explanations, new discoveries, a beginning of infinity right there on the moon.
Expanding that idea, take a typical empty cube of intergalactic space. If you prime it with the right knowledge,
It starts transforming. creating knowledge continuously, changing physically, becoming more massive, more diverse in elements, producing energy, using evidence, even developing error correction, becoming more resilient. A total transformation from inertness.
And the book ends on this powerful note. Most environments in the universe currently aren't creating knowledge. The universe is still young.
But they have the potential, like unimaginably vast quantities of explosives just waiting for a spark.
The spark of knowledge, leading to intense creation, transformation, changing the typical into something radically different.
And the final line really resonates. If we want to, we could be that spark.
Wow, okay. That's a lot to take in.
It really is. And the author helpfully defines some key terms. Person, anthropocentric, fundamental phenomenon, principle of mediocrity, parochialism, spaceship Earth, constructor, universal constructor, and what the beginning of infinity means in these contexts.
Right, so just to quickly recap the big takeaways then. The principle of mediocrity, spaceship Earth, useful metaphors maybe, but ultimately parochial, mistaken ideas if taken too literally.
From a less parochial view, people, because of our ability to create explanatory knowledge, are arguably the most significant things around.
And we support ourselves by creating knowledge and transforming our environment, not by being passively supported by some inherently benevolent biosphere.
The Enlightenment kicked off a process of knowledge creation that enables, in principle, unlimited future progress.
And while biological evolution also creates knowledge in genes, it's bounded, parochial, and slow compared to human explanatory knowledge.
Yeah, understanding the similarities, but also the crucial differences between biological knowledge and human knowledge is really important here.
The book also touches on how bad explanations for evolution, like Lamarckism, have parallels in how we sometimes misunderstand human progress, and how Paley, even though wrong about the designer, helped clarify that the appearance of design in nature is really about hard-to-vary adaptation, which does require knowledge creation.
Right. And a reminder that biological evolution optimizes gene spread, which isn't always the same as benefiting the species or the individual. And a brief mention that fine-tuning arguments aren't great evidence for the supernatural.
Okay. Phew. A truly expansive journey.
I definitely thought-provoking.
Absolutely. And we really hope this deep dive has given you, our listener, a fresh perspective, a new appreciation maybe for humanity's place, and the incredible power of the knowledge we create.
It really makes you reconsider those initial questions, doesn't it? Are we just chemical scum? Or is this ability to understand and create something truly unique and significant?
Is Earth this fragile little spaceship we have to tiptoe around? Or is it more like a pile of raw materials waiting for our ingenuity to unlock its potential?
We've really only scratched the surface of where these ideas could lead.
Totally. What does it mean for our future if problems really are, in principle, always solvable? What responsibilities come with being, potentially, that spark for the universe?
Big questions, the kind that stick with you.
And that is exactly the kind of mind-expanding stuff we love getting into here on The Deep Dive. If this chat sparked more questions for you, definitely check out The Beginning of Infinity itself or dig deeper into some of these concepts.
Yeah, we'd love to hear what you think too. What resonated? What challenged you?
Thanks again, sincerely, to you, our listener, for pointing us towards this incredible material. We are already looking forward to our next deep dive. We'll be venturing into the fascinating world of good explanations versus bad ones, perhaps, or maybe digging deeper into creativity and knowledge. We'll see.
Sounds good.
Until then, keep those questions coming and keep exploring.